Hello students. Today we are going to study about the basics of linked list. A linked list is a linear data structure in which the elements are not stored as contiguous memory locations. The elements in a linked list are linked using pointers as shown in the below image. As you can see, each node, these are called nodes, okay? So each node of a linked list is linked to the next one with the help of an arrow. What does this arrow signify? This arrow signifies that this portion of the linked list contains the address of the next node. So basically, every node of a linked list contains two parts, a data part and an address part. The data part contains any data which you want to store in that node. Here we have stored characters. You can store any other data type variables also. And the first element is pointed towards with the help of a pointer called head. The last node of the linked list, okay, has an address part which has the value null since it is not pointing towards any other node. So this is beautifully depicted with the help of this picture which we shown in the which we have shown in the first slide. So this you can see this chain, right? Okay, so this is the connection, and this first child is saying that I am the head, and the last one has an address part null. Now each item in the linked list is called a node and contains two fields. The fields are the information field, that is the data. It contains the actual element, and an address field, that is next. It contains the address of the next element. The next field of the last node, as I have already mentioned, contains a special value called null, which is used to signal the end of the list. The list with no nodes is called empty or null list. Now, how do we represent the components of a linked list? So as I already mentioned, again, it contains two parts, data and link part. All the other points in this slide are already mentioned before. A new point which we are seeing here is that every time we need a new node, we request memory from the heap. So linked list is stored basically in heap memory. This is a representation of a linked list. As we can see that the first node contains two parts, the data, that is 55, and an address part. What is this address actually? This address is actually the address of the next node. So this is a pointer pointing towards the next node. So I hope this picture is clear. This is the data part of the first node. This is the address part of the first node. This 48 is the data part of the second node, and 6100 is the address part of the second node. So as we can again see that 6100 is actually the address of the third node. So these are actually the addresses of each node. And the last node, since it does not point towards any other node, contains an address part null, which is depicted with n here. While representing a linked list, let us assume that we are going to create a linked list of integers. The one element, that is node, in the list needs to contain one integer and one pointer. So we can easily depict that particular linked list with the help of struct data type. So we already know that struct is used to create a user-defined data type, and here struct node is the name of the user-defined data type. It contains two parts. One is the integer part in the data, that is the data part of our linked list, and the next one contains the address part. So we see that it is struct node star link, which says that it is a pointer of struct node type. Linked list basically has three types: singly, doubly, circular. These are the basic types. So the linked list which we already saw in the previous slides, that depicts your singly linked list. So it is a collection of nodes linked together in a sequential way, where each node of singly linked list contains a data field and an address field which contains the reference of the next node. We have already seen this linked list in the previous slides. Next we come to the doubly linked list. Now in doubly linked list, we have two address parts and one data part. Now in a singly linked list, if we see carefully, we can travel, suppose we are traversing this particular linked list. Okay, we have started with 10, okay, then we are going to 20, then we are going to 30. Now after going to 30, if you suddenly feel that I should go back to 20, there is no other way. The only way to go back to 20 is you have to end the traversal. Again you have to start from 10 and then you can travel to 20. So there is no backward path present here. To overcome this problem, we have introduced, or we are studying, a new type of linked list, that is doubly linked list, which contains a data part and two address parts. So doubly linked list is almost similar to singly linked list, except it contains two address or reference fields, where one of the address field contains the reference of the next node and the other contains the reference of the previous node. This is actually called bidirectional linked list, since it allows traversal of nodes in both the directions. So the first and last node of a linked list of this type of doubly linked list contains a terminator, generally a null value, that will determine the starting and end of the list. This is an example. I feel this will make it clearer. So from 10, suppose we are starting with 10. Please note that the starting node's starting address, this is null, and the ending address of the end node, that is the last node, is also null. Now we can travel forward as well as backward. Now suppose we are going from 10 to 20, 20 to 30. After some time you can again travel back to from 30 to 20 by using this particular path. So here in the doubly linked list, each and every node contains two address parts, as you can see, this green part. So the first address part points towards the previous node. The second address part points towards the next node. Now we come to the next one, that is circular linked list. A circular linked list is basically a linear linked list that may be singly or doubly linked list. The only difference is that it has no null value terminating the list. In this list, every node points towards the next node and the last node again points back towards the first node. So it basically forms a circle. So it does not have any stop, since it is circular in nature. There is no starting or ending node. Whole node or whole, I can say the linked list, the whole linked list can be traversed from any node. In order to traverse the circular linked list, only once we need to traverse the entire list until the starting node is not traversed again. It has both the singly and the doubly type. Here you can see a circular linked list example. So as you can see, we can travel from 10 to 20, 20 to 30, 30 to 40. Again from 40 we can travel back to 10. This is a singly circular linked list where each and every node has one data part and only one address part, which points towards the next node. And the address part of the last node points towards the first node again. Now there is another variety of this type, okay. There's another variety called the circular doubly linked list. So it is a bit more complicated because each node here contains pointers to its previous node as well as the next node. It does not contain any null in any of the node. The last node of the list contains the address of the first node, and the first node of the list again points towards or contains the address of the last node in its previous pointer. I hope this diagram will make it clearer to you. As you can see, the first node here has two address parts. The first address part here, you know, points towards the last node, and the last node's last address part points again towards the first node. So this is a circular doubly linked list. Kindly note that in any type of doubly linked list, we have two address parts, and hence it occupies more space as compared to a singly linked list. So each type has its own advantages and disadvantages. I hope it helps you. Thank you, students.